Today we're going to do momentum in two directions. And we're going to have two objects. I think it's easier to call them A and B. When we call them A and B, instead of 1 and 2, sometimes we'll eliminate that double subscript also if we do prime. When we do these types of problems, it's just like any other problem we've done before. Conservation of momentum says the total amount of momentum remains the same. So what that means is the total momentum before is equal to the total momentum after. So before and after, what's in the middle? What's in the middle is an event. What we're going to do today, they involve collisions. And the collision is the event. So the event, when you look at it mathematically, is going to be the equal sign on the equation. Okay, that's what the equal sign represents. So let's look at this conceptually first. I have two objects, A and B. Now, normally, a lot of times when we do this, the problems that we're going to do today, B is a stationary object. A is moving. So momentum is a vector quantity. We know vectors have both magnitude and direction. How do we represent vectors graphically? We represent them by an arrow. So here's object A. This arrow represents the momentum of ball A before collision. Now remember, vectors have magnitude and direction. So the arrow, represents the magnitude, but at the same time, it's showing the direction. Okay? And then it hits ball B, which is stationary. Now, when I measure momentum, because I have these angles in here, I have to have a frame of reference for my direction. So you know how usually whenever we do problems, we use our standard Cartesian sign convention that up and to the right is positive? What we're going to use for our frame of reference in these problems is the original direction of ball A. So here, this represents after collision. So in this particular example, I have ball A moving off to the left of its original direction, and then I have the ball B moving off to the right of its original direction. And my frame of reference is the original direction of ball A, and that's why I drew it as a dashed line. Okay? In order to solve these problems, we're going to do what's called the momentum triangle. Okay? Now, we know that the one rule for adding vectors are added head to tail. So when you look at this, here, what I did was, this is the original direction of ball A. And we know that the total momentum before, is equal to the momentum of A plus the momentum of B. Well, B is 0 because it's not moving. So the total momentum before is going to be the momentum of just ball A. Now, graphically, this is, I put A plus B, but we know B is 0. So here's the total momentum before. Okay? Conservation of momentum says the total momentum before is equal to the total momentum after. But because momentum is a vector, I cannot just add it algebraically like we did in the other problems. Now I have to take the direction into consideration. So here is the momentum of A after collision. Here's the momentum of B after collision. So these two vectors added together, head to tail, should equal the other one. So this is, remember, here's my starting point, and here's my end point. So what I would do is I would take, this is actually A prime. This vector here represents A prime, and this PA prime. And this vector here represents PB prime, and the vector here represents PA. So, these two vectors head to tail, I start here. This is PA prime. This angle here is 30 degrees, because you see how that's 30 degrees? Then from the head of this vector, I do the tail of the other vector. So this vector here, head to tail, is this, which is PB prime, and this is a 30, 60, 90 triangle, so this is a right triangle. Now, if I can calculate this, if I have a right triangle, and I know it's a 30, 60, 90 triangle, and I know the hypotenuse of this right triangle, can I find the other two sides? Of course I can. So that just shows you how easy these problems actually are. And this is the way that we're going to do them. So these problems are really not that difficult, but these are the steps that you go through. Once you have this triangle, the problem is so easy. It's just a right triangle. And you know the hypotenuse, and you have to find the other two sides. And that's it.